Hey guys, very good evening everyone and welcome to today's session. We have been discussing about the domain analytics program by 360DigiTMG. And in this domain analytics, we have been specifically learning about cybersecurity analytics. Yesterday we discussed a lot about what is cybersecurity analytics, what are the different kinds of attacks, how to deal with that attacks. All these things we discussed yesterday. Today we will be talking about the project management methodology called as CRISpMLQ. Again, for whatever domain you are working on, when you are working on a project, you need a methodology in order to properly complete the projects you are working upon. So the methodology which we are discussing today, the name of that is CRISpMLQ. CRISpMLQ, guys, stands for Cross-Industry Standard Process for Machine Learning. And today's agenda will be, we will be discussing about stages of analytics. We will be discussing about CRISpMLQ methodology, inferential statistics, what is supervised and unsupervised learning, right? What is data split, error function, overfitting versus underfitting. All these things will be having an overlook of. Okay, proceeding further. So when I talk about your, stages of analytics, so these are the 4 stages of analytics. The first stage is descriptive analytics. Second is diagnostic, then predictive and analytics, prescriptive analytics. These 2 stages talk about your past and present. What happened in the past? How many COVID cases, occurred? How many people succumbed to COVID? How many people got inoculated? All these things is what is discussed in descriptive and diagnostic analytics. When we talk about your prescriptive and predictive analytics, here we are dealing with the future. A person who talks about your past and the present is called as your data analyst. A person who talks about your future is called as your data scientist. Data analyst, they use, your business intelligence tool as in your, Power BI or Tableau to, present the analysis or do the analysis. Whereas a data scientist, though he only talks about the future, but he needs to possess the quality of a data analyst as well. Okay. Proceeding further. Project management methodology, what we have been talking about is CRISpMLQ, cross-industry standard process for machine learning along with your quality assurance. What happens is when you start working as a data scientist, you need to work on various projects pertaining to different domains it can be. Here, what happens is once you have been given the project by the client, okay, you get the business problem. Now, once you have the business problem, you try to understand about it and you record your objective and constraints, right? Once you have your objective constraint, then other things are there. Then you do your data collection. Once you have done your data collection, most of the times you will be collecting it from your secondary data source. That will be having a lot of ambiguity in it. It will be having a lot of duplicate values kind of stuff in it. So you prepare your data. Then you proceed for your model building and tuning. Then you do the model evaluation. Model building, you have the data set, you have the model with you. You use that, right? And you fine tune it depending about whether check the accuracy, whether it is providing the good accuracy or not. If it is not providing you the good accuracy, then again you fine tune the model. You do the evaluation. Once you are totally satisfied, you deploy the model. Once deployment is done, every 2 to 3 months, you keep on monitoring whether that model is working fine or not. If it is not working fine, you provide the maintenance. This is your project management methodology. Then we have something called as the supervised and unsupervised learning. Talking about your unsupervised learning, what is unsupervised learning? Now, as per the name suggests, unsupervised learning is a machine learning technique, guys, in which models are not supervised using training dataset. Instead, what happens is model itself find the hidden patterns and the insights from the given data. Now, it can be, compared to say learning which takes place in your human brain. As in, when we try to teach something to a kid, this example I was telling yesterday. What happens is you give the kid, various kind of different colored candies, toys. If you're trying to make them understand about the red color, you give them red candy, red toy. Initially, what will happen is after some days, if you give them, a blue color candy or toy, they will say that no, it is not a red color. Okay. So when I say it can be compared to learning which takes place in the human brain while learning new things, what I mean to say is that your unsupervised learning can be defined as type of machine learning in which models are trained. Let me jot it down for you guys. Models are trained using unlabeled dataset, guys. Unlabeled dataset. And are allowed to act on that data without any supervision. Unsupervised, right? As the name is suggesting, unsupervised. Now, unsupervised learning, guys, it cannot be directly applied to a regression or the classification model. Or you can say it cannot be directly applied to your regression or your classification problem. Because unlike supervised learning, we have the input data, but no corresponding output. We don't have any corresponding output data. The goal of the unsupervised learning is to find the underlying structure of the data. Group that data. Now, once we have this data set, then we group that data according to the similarity and represent that data set in a compressed format. Example, suppose the unsupervised learning algorithm is given an output data set containing images of different types of dogs and cats. The algorithm now, guys, we know that it is never true upon this given data set, which is having this picture of dogs and cats, which means that it does not have any idea about the features of the data set. Now, the task of the unsupervised learning algorithm is to identify the image pictures of their own, image features of their own. Getting the point? Unsupervised learning algorithm will perform this task how? It will perform this task by clustering the image. Clustering the image dataset. And how it will cluster? It will be clustering the image dataset into the group according to similarities between the images. But now the question arises, why? Okay, all these things are fine, but why? Why unsupervised learning? Why do we use? The first thing which I would like to bring to your notice is unsupervised learning is helpful for finding useful insights from data. From data. First, second thing, unsupervised learning is, much similar to your human brain. As a human brain, learns to think by their own experience. Hence, it makes it closer to AI. You randomly ask any question to Alexa, it is going to give you the answer. Closer to AI. Second thing, third thing, unsupervised work, unsupervised learning, it works on unlabeled and uncategorized data, which hasn't been categorized or labeled before. We know that, right? Now, working on that unlabeled and uncategorized data makes unsupervised learning more important. In real world, we do not have, always have input data. We do not have. With the corresponding output, we rarely do have the input data. So in order to solve such kind of cases, we need unsupervised learning because it works on what? Unlabeled data. Unlabeled or uncategorized data. All right. So this is why we are using, or these are the benefits of using your unsupervised learning. Now, once we know what is the unsupervised learning, the question again remains, okay, fine, we know unsupervised learning, what it is, and why should we use it, all these things we have learned. But how to do that? Is there any algorithm you can tell me that comes under the unsupervised learning? Yeah, of course, there is. The first algorithm is called as the k-means clustering. K-means clustering. Second one, KNN, also called as k-nearest neighbor. Third one, hierarchical clustering. Yes, clustering. Fourth one, anomaly detection. Another, neural network. We all have heard about all these kinds of algorithms, right? We have even studied few of them, or most of them, I would rather say. We have also studied about principal component analysis. Then there is something called as independent component analysis, IC. Then we have a priori algorithm. A priori. We also studied about a singular value decomposition, also called as SVD. All these are the various algorithms for unsupervised learning. And this is how you train your data. Historical data is taken to the machine learning, and based on that, we get the rules and patterns. But when we talk about your prediction, no, my bad. Yeah. When we talk about the prediction, a new data is taken, and rules or patterns are, this. A new data is taken, rules and predictions are, preset, and then your rules and patterns are set, and then you predict whatever is going to happen. Okay, moving ahead. Now we understood about the unsupervised learning. Then we have something called as supervised learning as well. Now we will try to understand about the supervised learning. Remember, we are discussing all these topics before, even before talking in depth about whatever domain we are going to discuss about. We should have an idea of how the things actually work in the real world scenario. So we are just taking up the points which is necessary to discuss the depths of the domain for which we have gathered over here. So today we are discussing about the project management methodology. And gradually in the coming sessions, we will be discussing, regression techniques and supervised learning in coming sessions for cybersecurity. So then we have something called as supervised learning. Supervised. What is supervised learning? Supervised learning is the type of machine learning in which machines are trained using well-labeled training data. Previously, what happened in the unsupervised learning, we were getting a data which was having no label, which was having no category, right? But here in supervised data, we train the machine. We train the machines using the labeled training data, and on the basis of that, machines predict the output. What will be the output? When I say the labeled data, what I mean is some input is already tagged with the correct output. Previously, it was not happening, right? When we were discussing about unsupervised learning, it was not happening over there. But here, when we have the labeled data for our training, labeled training data, when we are having that, then what happens is some input data is already tagged with the correct output over here. Also, what happens in supervised learning, the training data provided, the training data which is provided to your machine to work as the supervisor guide, to teach the machine to predict the output correctly. That is our end goal, right? We want the correct prediction. Our prediction should be as much as accurate we can get. That will be better for us. So in unsupervised learning, the training data provided, so the machine works as the supervisor that teaches the machine to predict the output correctly. Now it applies the same concept as the student learns in the supervision of the teacher. You guys attend various trainings, right? All these things are going on. So what happens is you are actually learning under the supervision of a person who is already trained, means he is having some labels, right? So this is the whole idea behind it. So initially, if I were to say supervised learning is a process of providing input data, process of providing input data as well as correct output data. Where? To the machine learning model, to the machine learning model. Now, the aim of the supervised learning algorithm is to find a mapping function, or I would rather say is to find a, is to find a mapping function to map the input variable, say X, with the output variable Y. This is the whole goal of your supervised learning. What it is? It is to find a mapping function to map the input variable with your output variable. That is it. That is the whole scenario. Now, in the real world scenario, supervised learning can be used for various things. When we talk about, risk assessment, as in, if you are using a bank's credit card, every bank has its team of, risk assessment officers or risk assessment team. What eventually happens is that when you make a transaction, they assess it, whether the transaction which you have made is fraudulent or not fraudulent. If it is fraudulent, they are immediately going to call you and tell you that, what, this is a transaction made by your credit card and we think that this is a fraudulent transaction. So if you confirm, we can block it, otherwise that is fine. So risk assessment is one place where we can use our supervised learning. Image classification. Image classification is yet another example where we can use your supervised learning. When we talk about fraud detection, when we talk about spam filtering, ever imagined you are getting so much, mails in your Gmail or Yahoo Mail or Reddit Mail? It is categorized into, inbox, spam, bulk, junk, all these options you get in your mail ID, right? This is something which can be used for all the things, spam filtering, fraud detection, and many other things as well. How does this supervised learning works, guys? Let us see how this supervised learning works. What happens is that in supervised learning, the models are trained using the labeled data. Models are trained using the labeled data, where the models learn about each other, right? When we are having the trained data, labeled data, what initially will happen? The models will learn about, each type of data. Now, once the training process is completed, once the training process is done, the model is tested on the basis of test data. See, test data prediction. Test data used for our prediction. And then it predicts the output. It predicts the output. The working of a supervised learning guide, Suppose we have a data set. Let us understand it in this way. Suppose we have a data set of different type of shapes, which include your, say, we are having a square, we are having a rectangle, say we are having a, a triangle, various shapes we are having. Now, what will be the first step? The first step is that we need to train the model for each shape, each pattern. We need to train the model. If the given shape has, say, 4, we have a polygon also. If the given shape has 4 sides, then all sides are equal. It will be labeled as what? Square, right? Having 4 sides, all sides are equal. If the given shape has 3 sides, then it will be labeled as triangle. If a given shape is having 6 sides, it will be labeled as hexagon, right? This is how we are going to make the machine learn about various kinds of shape. Now, after the training, we test we are also testing, we test our model using that test data. And the task of the model is to identify, here what will be the task will be, see here what we are doing. This is training and validation. We are using all these shapes, we are giving it to the machine to learn about it, right? We have this some historical data. By applying the random sampling, we split the data into the training data set and validation data set. Training data set initially we give to the machine learning, where it is going to learn about the variation and come up with a mathematical equation. Now, when we use the validation data set, we apply this mathematical equation over it and we do the prediction and the validation. And then we get a model validation outcome. Now, what we do over here is we are trying to do prediction on a new data. See here, we are having our data on which we have trained it. That is fine, understood. But here, what is happening is we are having a totally new data set. We take the new data set, do the prediction using the mathematical equation we got over here, and we get the predicted outcome. That is. So after training, we test our model using the test data, and the task of the model is to identify the shape by this example. Now, since the machine is already trained on all types of shapes, and when it identifies a new shape, what will happen? It classifies the shape on the basis of what? We are saying various sides. If it is having 4 sides, all are equal. 3 sides, 6 sides. So when it will get a new kind of data, when it classifies a new shape, it classifies the shape on the basis of the number of sides, right? And then it predicts the outcome. Got it, guys? Now, once this is done, then what are the steps in the supervised learning? The first step is to determine the type of training data. Type of training data set. Then you collect the labeled data. You collect it. Now, once you have collected, you split it. Splitting the data set into training data set, test data set, and validation data set. Then you determine the input features of the training data set. What is going to be your various input features? Like, for the shapes we were seeing, 4 sides, then it is going to be your, a square. If all the sides are equal, 3 sides, then it is going to be triangle, that sort of. So determine the input features of the training data set, which should have enough knowledge so that the model can accurately predict the output. Then you determine the suitable algorithm for the model, such as support vector machine decision tree on the basis of training data set. You execute it, right? And then you evaluate. Then you evaluate what? Evaluate the accuracy of the model by providing the test data. We are giving the test data. And if the model predicts the outcome correctly, it means that our model is accurate. In test data, we already know what the thing is going to be. So if you try to get that, result prediction and it is matching our knowledge, then we can say that the model is very. Now, what are the types of supervised learning? First one is the regression. Another one is called as a classification. When we say regression, then linear regression, regression trees, non-linear regression, polynomial regression, all these things are there. And when I talk about classification algorithms are used when the output variable is categorical, which means there are two classes such as yes or no, male or female, true or false, so on and so forth. For the classification, if I talk, then random forest, decision trees, logistic regression, support vector, machines, all these things. And when we were talking about the regression, then regression algorithm, it is used if there's a relationship between the input variable and the output variable. Also, it is used for the prediction of continuous variables, such as if I were to give an example, it would be of weather forecasting, market trends, all these kinds of things, right? Okay, moving ahead. We already discussed about training, validation, and testing, all these things we discussed. Then we have something called as confusion matrix. The confusion matrix, guys, is a matrix used to determine the performance of a classification model for a given set of test data. Now, it can only be determined if true values for the test data are known. The matrix itself can be easily understood. If you read this, we can make a lot of understanding by just reading through. Predictive class is positive or negative. Diseases present as positive or negative, or actual class is a disease absent. That is. Why is categorical? So your output is always going to be categorical. The matrix itself can be easily understood, but the related terminologies can be confusing, guys, since it shows error in the model performance in the form of the matrix. Hence, this is also known as your error matrix, confusion matrix, error matrix. Some of the features that I would like to tell you guys is, okay, by seeing this, when we are getting a true positive, it means patient with disease is told that he or she is having a disease. If we are getting, true negative over here, then what will happen is patient with no disease is told she does not have disease. If we have false negative, patient with disease is told that she or he does not have disease. When we are getting false positive, patient with no disease is told he or she has disease. So much confusion, right? So much of confusion. How to calculate your accuracy? We have this formula: true positive plus true negative divided by true positive, false negative, false positive plus true negative. All these are the various formulas for calculating your accuracy and error. But again, very confusing, right? It is very confusing. That is why this is called as a confusion matrix. So discussing about the features of the confusion matrix, if I were to say, for two prediction classes of a classifier, the matrix is of what? If there are two classifiers, it is going to be 2 by 2 matrix. If three classes are there, then it is going to be 3 by 3 matrix or table, and so on. 4, 5, so 5 by 5, 6 by 6, all these. This is how you represent your matrix. Now, the matrix is divided into only two dimensions, that are predicted value and actual value, along with the total number of predictions. Predicted values, guys, are those values which are predicted by the model, and actual values are those values, or you can say these are the true values for the given observation. Okay. So what is true, negative, true, positive, all these things? When I say true positive, so what actually is happening is the model has predicted yes over here, and the actual value is also true. The actual value is also true, prediction value is also true, hence true positive. When I say true negative, what is happening over here? Though your model is giving prediction no, but the real or the actual value is okay, no. The model, sorry, I also got confused while teaching about the confusion matrix. True negative, guys, the model over here gives the prediction no, and the real and or the actual value is also your no. That is your true negative. Both are giving no. When you talk about the false negative, what happens is the model has predicted no, but the actual value, that is yes. It is called as your false negative. When we talk about false positive, the model has predicted yes. Prediction is yes by the model, but the actual value is no. Now, when we talk about false negative, this is also called as your type 2 error. When we talk about your false positive, this is also called as your type 1 error. Okay. Moving ahead. Okay, all these are your, various things, various functions. There is a function called as precision, in which your true positive is divided by the summation of true positive plus false positive, and it is equal to true positive divided by your predictive positive, which is actually equal to your probability of correctly identifying a random patient with diseases or having diseases. Then we have sensitivity, also called as recall or hit rate or true positive rate. And this is the basic formula for calculating your sensitivity. Seen by the previous example, how this is going to help, it is going to give the proportion of the people with disease who are correctly identified as having diseases. Then there is something called as specificity, true negative rate. Formula is true negative divided by true negative plus positive, false positive. That is equal to your proportion of the people with no disease being characterized as not having disease. False positive rate, also called as alpha or type 1 error, which I was telling you previously, is equal to 1 minus specificity divided by false negative rate, also called as your false negative. We know that it is called as your type 2 error. F1 is to 1 to 0 and defines some measure that balances the precision and recall. So many things are there. Besides this, if I were to say, okay, all these things are fine, but what is actually the need for confusion matrix in machine learning? So what it does is, guys, it evaluates the performance of your classification models when they make, predictions on test data and tell how good our classification model is. It not only tells that the error made by the classifiers, but also the type of errors, such as it is either type 1 or type 2 error. With the help of confusion matrix, what we can do is we can also calculate the different parameters for the model, such as your accuracy, precision, so on and so forth. Okay. Let me give you guys an example to make the thing. Oh, already we discussed this example, right? So I think that is enough. Or let me give you one more example. Suppose we are trying to create a model that can predict the result of the diseases as we were discussing this. Okay. So what we are trying to do is we are trying to predict that a person is having a disease or not. So the confusion matrix for this is given as what? We are just trying to exaggerate that previous examples that we were seeing to make this concept of confusion matrix more clear. Say n is equal to 100. Then say actual is equal to no. Then say actual is equal to yes. And let's say predicted is equal to no, is equal to 65, predicted is equal to yes. Let's say false negative is your 8 is equal to 8, total 73. In the same way, false positive over here, suppose it is 3, your true positive, suppose it is 24, let's say, total it will be your 27, 68 total over here, and the total over here is 32. Let us try to understand this. Now, from this example, we can conclude that the table is given for two classifiers, which has two predictions, yes or no, right? See here, yes and no. Here, yes defines that the patient has the disease and no defines that the patient does not have that disease. We know. Now, the classifier has made a total of 100 predictions. Out of 100 predictions, 89 are true predictions and 11 are incorrect predictions. The model over here has given the prediction that yes is 32, whereas the actual no, or okay, whereas the actual yes is 27. See here. And actual no was 73. So by this example, we can make the things more understandable of how the things works for your confusion matrix. Moving on. These are the various error functions, When y is continuous, these are the functions which we can use. Suppose in the actual data, we are having the value 100 and forecast made on the, based on the first model, which we prepared, it was giving us value of 101. So the error from this model is of one value. Forecast made based on the second model is 10110. What is the error? We have the error of 10. When we have the actual data of 200, forecast based on the model 1 is 199. So here, what will be the error for the model 1? That is going to be -1. Forecast from the second model 190. Error will be -1, so on and so forth. Various types of functions, mean error, mean absolute deviation, mean squared error. These are the various formulas. you take the square root, you take the mean percentage error. All these are the various functions. When your output is continuous, accuracy percent plus your error percent is give you 100%, and accuracy plus error will be always equal to 1. But that is something, when we have the output as continuous. Okay. Then in our agenda, we were also discussing about, model evaluation and tuning. So here, this is the representation of our regression model over here. And this is how the things happen in the classification model, right? Here, what is happening is prediction is too, inflexible. We cannot capture the patterns over here. And see here, there is too much noise in the data, Getting the point? So for the balanced data set, how we do the things? We split the data randomly to avoid the bias. We don't want our data to be biased, right? And after splitting, what we do is we take the 60% of your training data, whatever data we got, we split it. And out of that, we take the 60% for training. 20% is what we take for our validation. Remember a few minutes before we were talking about training data, validation data, and testing data. So if we have a data set, right, we cannot say randomly like this much data I'm going to use for, training, and this much I'm going to use for the validation. If you do that randomly, then it is going to have a lot of biasness in it. We don't want that. We want our data to be completely bias free. So these are some of the scales which we use to split our data. 60% we use for the training, 20% we use for the validation, and the rest of the 20% we use for our testing. We take the 80% into training and 20% into testing. Either this way we can do that, right? There should be a rationale behind it. Randomly, you cannot do anything. There should always be a rationale behind it. Your large data set, suppose most of the times you'll be working on the large data set. So when you work on the large data set, what happens is large data set is equal to, estimate future error as accurately as possible. Whereas when we have the large training data set, then it gives us the better estimates, right? All these things are there in the when we talk about choosing the balanced data sets. So all these factors we should keep in mind while choosing the balanced or while preparing the balanced data set. These are the issues which we face: overfitting and underfitting, right? In order to solve all these issues, these are the things, these are the steps that we need to follow. Okay, moving on. All these things are fine, whatever I told you, but what is actually the meaning of overfitting or underfitting? Well, overfitting, guys, is a statistical model. When we have a statistical model, and if a person says that it is overfitted, it means that when we train it with a lot of data, and when a model gets trained with so much data, it starts learning from the noise. See here, we were having a lot of noise in our data, right? If we see this image, so we are having a lot of noise over here. Okay. So when a model gets trained with so much data, it starts learning from the noise and inaccurate data entries as well, right? Whatever inaccurate data, see, what we do is we collect the data from the secondary data source. And we all know this is a known fact that, when you collect it from a secondary data source, it will have a lot of inaccurate data entries, right? It will be having duplicate values. It will be having, typecasting issues will be there, ambiguity will be there. So your model gets trained. When it is getting trained with so much data, it starts learning from the noise and the inaccurate data entries. Then the model does not categorize the data correctly because there are too many patterns, right? There are too many inaccurate entries, too many, because of too many details and noise. This is called as overfitting. And when we talk about underfitting, a statistical model or a machine learning algorithm is said to be underfitting when it cannot capture the underlying trend of data. Here we are having a lot of trends over here, lot of noise. It is not able to categorize so many. Like, when you go, sometimes what happens is when you go to buy a cloth, you go in a clothes showroom, and when you start seeing a lot of options, right? A lot of options are there. You are not able to categorize. Okay, you even forget what is specification you had in your mind before you came for the shopping. That is overfitting. And when we talk about underfitting, it is nothing but when we are not able to capture the underlying trend of the data. What happens is underfitting actually destroys the accuracy of the machine learning models. And its occurrence simply means that our model or the algorithm is not having the well-fitted data. That is, this is the basic difference between your overfitting and the underfitting. So guys, this is where we are going to end the session for today. Thank you so much for joining. And in the coming days, we will be continuing learning for our cybersecurity analytics. Thank you so much, guys, for joining. Have a wonderful evening, everyone. Keep learning, guys. Thank you.
Thank you.
Thank you, guys.
Sir, can you share the PPT?
Kawali, I'm not sure, but put the request in the Telegram group and let's see if I can do that.
Sir, can you send me the Telegram group? Link.
Telegram group link you want?
Yes, sir.
Okay, just a moment. I will share that.
Okay, sir.
Guys, I'm not able to get the hold of that link. I will try to share the link tomorrow, guys. Don't worry. We have the training for coming 2 days. So tomorrow for sure I will share the link. Okay. Rakesh, is that fine?
Okay.